So this one is written June 2020, Unit 5, but that is conducted because there was no exam in June 2020. The results were predicted result. So this same paper came in October exam. The Unit 5, in the first question, the radiation detector is placed near a radioactive source and measure the count rate from a source. And different absorbers are placed between the detector and the source. The results are shown. So when nothing is placed, it was 850. When we place a paper, the counts does not change. Paper is able to stop alpha. So if count does not change, it means there is no alpha. When we place an aluminum foil, the radiation decreases to 150. So it means there is beta, as there is a considerable change in count.
Hmm.
And then lead sheet. So lead is able to stop gamma and considerable change. So it means there is gamma as well. This shows there is beta, but the first one shows there is no alpha. So which of the following is emitted from the source? It is emitting out beta and gamma. Next question. The graph shows the binding energy per nucleon vary with the nucleon number. Which of the following conclusion is supported by this graph? So the first one, the first option, total energy release is greater when two low masses nuclei fuse. If two low masses nuclei fuse, like example 4 and 4 fuse together, so the binding energy per nucleon increases. But as you can see, the difference in the binding energy per nucleon is more, so energy release will be less. If the difference in the binding energy of the two nuclei is less, then the energy release will be higher, because basically what happened, some of the energy release and remaining rest of that binding energy, the rest of the energy is used to bind the nucleon. That's why if the binding energy increase more, the energy which is released will be less. So total energy released when the two low masses nuclei fuse, that will be greatest. That's wrong. Total energy absorption can not be an answer. Why it cannot be an answer? Because these reactions are exothermic, and even fission and fusion both are exothermic. So exothermic, they cannot absorb, they always release energy. So which one appear to be a right statement? Part C is the total energy release is greater when massive nuclei undergo a fission, because when massive nuclei undergo a fission, what will happen, the change in the binding energy is small, so energy release will be higher. From this graph we can conclude this. A closed container holds a mixture of two gases at a constant temperature. Each molecule of a gas has a mass 4 times the mass of each of molecule of Y. The molecule X has a mass 4 times. What is the root mean square speed? So the temperature is same, so means the temperature of X is same as temperature of Y. If they both have the same temperature is same, so their kinetic energy will be same. So it will be half mv square for X, and this will be half. They mentioned the mass of X, each molecule of X has mass 4 times. So this is 4m, this one is m, and then root mean square speed of y square. So half will cancel with half, m will cancel with m, so we are left with 4 root mean square speed of x, root mean square speed of y, and when we simplify, x square y square is equals to 1 by 4. But we want the ratio between the speed, not the square. So when we take a square root, under root, so it will turn out, because when we take under root of 1 by 4, that will be 1 by 2. So for question 3, the right answer is B. A negative temperature coefficient thermistor and a resistor are connected as shown. The temperature of a thermistor decreases. Select a row that shows that how the reading of the meter changes. So for thermistor, when we increase the temperature, its resistance will. When we decrease the temperature, its resistance will increase, and when we increase the temperature, its resistance will decrease. So opposite. So here, what happened? The thermistor temp, temperature is decreased, so its resistance will increase. So when resistance increase, because they are in series, so combined resistance will be resistance of thermistor plus resistance of fixed resistor. Resistance of thermistor is increased, the fixed resistor is constant, so combined resistance will increase. As the combined resistance increase, the reading and the current will decrease. And voltage, they're asking, because this is also a potential divider circuit, so potential divider circuit divide the voltage between the two components, and it divide as a ratio. The one which is having a high resistance will have more voltage, and the one which is having a low resistance will have less voltage. So compared to fixed resistor, thermistor is having high resistance, so more voltage across thermistor and less voltage across a fixed resistor. So voltmeter reading will decrease, and ammeter reading, because the total resistance is increasing, so ammeter resistance will decrease as well. A simple pendulum takes 1 second to swing from one extreme position to another. Which of the following gives the length? So we have the formula T is equals to 2 pi under root L divided by G. So T is the time period from one extreme to another. So moving from one extreme to another, the time period is time to complete one vibration, but going from one extreme to another and then coming back, that will be the time period. So the time period is not 1 second, time period is 2. And this will be 2 pi under root L, and the gravity is 9.81. When we solve this, to remove this square root, we'll square both sides. So this will become 2 square, this will be 4 pi square, and then L divided by 9.8. When we simplify this equation, L will be equal to 2 square multiplied by 9.8 divided by 4 pi square. So it matches with option B. Next question. Question 6 and 7 both related to experiment carried out by a student to investigate the absorption of gamma radiation by lead. The student used a GM tube to measure the background counts for 10 minutes. He then used the apparatus below to measure the counts for 2 minutes of different thickness of the lead. To correct the reading for the effect of the background, what a student should do to for a corrected background radiation. So she measured the background count for 10 minutes, and then operators measure the count for 2 minutes with different thickness. How she will know that how many are there due to the source? So by taking a difference of the two counts, subtracting the back, because the corrected reading, the radiation from the source, so if we minus the background count from the total reading, we can find how much or what is the radiation from the source. The student discovered that the thickness of 1 centimeter of lead reduced the corrected count rate by 50% of initial value with no lead. Which of the following statement is correct? So thickness and count rate, the amount of radiation which are passing, they are inversely proportional to each other. So number of the counts and the thickness, because if I use a thick lead, the number of the counts will reduce. So if the thickness is doubled, like example, first it was 1 centimeter, if I made 2 centimeter, then the count rate will reduce by 2. So if it was 50% when 1 centimeter, half of 50%, that's 25. So that's why C is the right answer for question 7. Question 8. A solid is heated and it's melt at a constant temperature. Which row shows how the kinetic and the potential energy? When the substance is changing a state, there is no change in temperature. There is no change in temperature, there is no change in kinetic energy. And what about potential energy? The energy is used to break the intermolecular forces. So the potential energy will increase. That's why C is the right answer. Question 9. A student hangs a mass from end of a spring and set the mass into vertical oscillation. The period is T. She then hangs the same mass from a second spring with a spring constant 4 times the first one. What is the period of oscillation of a mass? So we have the formula which relate the time period, that is T is equals to 2 pi under root K divided by M. Sorry, M divided by K. I think I said K divided by M. It's M divided by K. So 2 pi under root M divided by K, and for pendulum it's 2 pi under root L divided by G. So constants are there. So this shows a relation that T is inversely proportional to square root of K. So what happened? It becomes 4 times. So one is increased, the other should decrease, but with a square root. So square root of 4, that's 2. That will decrease by 2. That's why for question 9B will be the right answer. Forcing system into oscillation may result in resonance. Resonance means when one object forces the other object to vibrate by applying a frequency same as a natural frequency. For a resonance to occur, the oscillating system must be driven at its natural frequency, because when it is driven at a natural frequency, maximum energy is transferred and it will vibrate with a maximum amplitude. So these are MCQs from the paper June 2020, which was conducted in October 2020.